Number 17, let f of x be e to x minus 1 all over x. Find the Taylor series at 0 for f of x. For what values of x does the series converge? Give your reasons. Find the 100th derivative of f at 0. Okay, so let's first find the Taylor series. Okay, so can we start with something we know, or do we have to do the brute force way of taking derivatives, plugging in x is equal to 0, trying to find a general pattern? Let's always try to start with something that we hopefully memorized, and looks like the clue is e to the x, so maybe let's start with that, all right? So if we remember the Taylor series for e to the x, it's 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus so on and so forth. Or we can remember as summation as n goes from 0 to infinity, x to n over n factorial. This is quite easy to remember, so I remember it like this, okay? So pretend there's an equal sign there as well, okay? We can subtract 1 on both sides of the equation, okay? Okay, so I now recalling why I purposely wrote out the expand form here, okay? If we treat it like an equation, subtract 1 from both sides, so e to x minus 1 is equal to, if we subtract 1 from this side, it's just x plus x squared over 2 factorial plus x cubed over 3 factorial plus so on and so forth. This 1 goes away, okay? So we can essentially rewrite this right-hand side over here, or I guess the middle over here, equals, instead of starting from 0, we start from 1, okay? And then to get this to match this up here, we just divide by x on both sides now. So e to x minus 1 over x, we divide by x over here. So that's the same thing as subtracting 1 power from this x over here, okay? So it's x to n minus 1, okay? What's the interval of convergence? That's what this is basically asking. For what values of x does this series converge, okay? If we have some basic intuition, I should say, remember the radius and interval of convergence of e to the x, it was infinite, the radius of convergence. So it converges for minus infinity to infinity, okay? This will likely converge for all values of x as well. We didn't do anything really to make the radius of convergence possibly change. Okay? So that's our intuition, but we have to, or it's if we say it like that, we probably won't get the credit, to be honest. So let's just do it and let's just find it explicitly. And how do we do that? We do the ratio test, okay? But it's always good to have some intuition. So here's the setup for the ratio test. A sub n plus 1 divided by a sub n, right? So this x to n plus 1 minus 1 simplifies to x to n, but we have x to the n divided by x to n minus 1. We subtract the power, so that's just x to first power, okay? And n factorial divided by n plus 1 factorial. N plus 1 factorial is n plus 1 times n factorial, so those n factorials cancel. We're left with n plus 1. We take the limit as n goes to infinity, it is 0. So our intuition checked out, okay? So we have to give our reasons. So we say that the radius of convergence is infinite, which means the series converges for all values of x, okay? This doesn't depend on x, right? And what does the ratio test say? If the limit is less than 1, which it is, it's absolutely convergent, okay? Now, I explained this in the previous problems, if you're watching this sequentially. To find the 100th derivative at 0, we need the coefficient out in front of the 100th degree term. And then we multiply by 100 factorial, and that's it. These are quite simple, to be honest. If we understand the concepts, which I explained in, I believe, what number is this? 17, 14? Whatever I filmed not long ago. I'm filming this out of order, but anyway. So what was the general form? Right here, right? How do we get x to the 100? That's n equals 101, correct? So what's the original coefficient out in front? It's 1 over 101 factorial, okay? And then we multiply by 100 factorial because this is the 100th derivative. We're going to be taking 100 derivatives, so that's the power rule. This is the effect of an effect of the power rule, this 100 factorial right here, okay? So this simplifies to 1 over 101. And that's the answer for this